All right, now that you've read everything about fractions, adding, subtracting, multiplying, and dividing, I just wanted to do a little recap before we met again in class. So the big idea for adding and subtracting is that you have to have a common denominator. And why is this? It's because if we're adding things, how do we know how much to add if we don't have equal sized parts? That's what the common denominator means. It means we are breaking the wholes into equal sized parts. So think about subtraction. If we had 9/10 and we wanted to subtract 3/4 from that, well, how do I know what 3/4 is if I don't have the same size parts? So the goal is to get the same size parts or have a common denominator. Now I know that some of you might be thinking, well, I can do 3/4 minus 1/2 in my head. Yes, that's the goal, but we're still thinking in terms of quarters to know how many parts to remove. So yes, that's where we want to get gradually, but when you're building that foundation with your students, using the idea of equal sized parts. On page 14, thinking about this, how can you use the idea of equal sized parts to help explain to the students in number 3 who had some incorrect work? How do we use this point to drive that home to them and help them fix those misconceptions that they're having? The next thing that you talked about or read about was multiplication, and I hope you recognize that the area model is very similar to that we've used with whole numbers, but this time we're looking at shaded regions because instead of having whole numbers, we only have part of a whole, so that's why we shade it. And then looking at the 2 dimensions, we can look at what regions overlap and see where they're double shaded, aka the overlapping region, to see what the product of our multiplication problem is. Now, one thing I did want to talk a little bit more about, and I didn't draw a picture. I took a picture from the textbook. And it said to think of fractions in sets. So like in the problem, I believe it was 1/2 times 3/4. Yes, 1/2 times 3/4. What does this mean? And think about that in terms of whole numbers. Well, if we had 4 times 5, we would know that that's 4 sets of 5. But here, I want a half a set of 3/4. So what I did was I drew 3/4 of these are blue. And I want a half of what I have. So if I were to split these 3 in half, my line would go right down the middle of that middle blue one. As we can see, I split my 3 out of 4, I split them in half. Now I'm going to circle it just to make my point. This is 1/2 of a set of 3/4. So I have my 1/2 of this entire group. The group is 3/4 in this case. So now to figure out how many I have, since I had to split this one down the middle, I'm going to split them all down the middle. And instead of fourths now, I can see that I have 1, 2, 3, 4, 5, 6, 7, 8 equivalent parts. So I have 1/8, 1/8, and 1/8 included in my half region, in my half set. So therefore I would have a total of 3/8. All right, so hopefully that helps you see the visual relationship, but also the tie to the whole numbers that we have been talking about. And then the last one is division. So looking like whole numbers, I believe the example in there was 6 divided by 2. We know that we need to take the whole 6 and divide it into equal parts of size 2. Just like we did with decimals. When we have decimals, we still have to divide it into those equal subgroups. The same goes with fractions. When we're dividing, we want to split them into equal size subgroups. So the example that they had in the text was, the one that was drawn out visually for you, was we have 1 3/4 and we want to see how many half size groups we have. So that visual does a really nice job of shading in having 1 3/4. And in that whole one, we can see that we have 2 halves. And then in the 3/4 group, we have another half, but then we have this little teeny tiny piece left over. So far I have 3 halves, but this piece is a half of a half. So I have 3.5 groups of halves. Confusing, right? But the whole point is that we're taking out those equal size subgroups. Now, the last page has several examples, and you're going to see that they're similar in the quantities that you're using, but they differ in what they're asking for. So you have to decide based on each one if you need to multiply, divide, add, or subtract to figure out what we're actually looking for. So if you have questions, make sure to circle them, write them down, and we will discuss those when we meet next.